Hello students, welcome to my channel. In this class I am going to teach you eigenvalues of a square matrix, eigenvectors of a square matrix, and how to find the eigenvalues and eigenvectors of a square matrix. Let us start the topic. So first of all, you see definition of eigenvalues of a square matrix A. Let A is equal to square bracket Aij n cross n matrix. It is a square matrix of order n. Then the value of lambda for which this equation Ax is equal to lambda x, it will satisfy. This equation will satisfy. Has non-trivial solutions are called eigenvalues of A. Eigenvectors. Let lambda be an eigenvalue. Then the non-zero vectors x for which this Ax is equal to lambda x holds are called the eigenvalues of A. Next characteristic matrix. The matrix A minus lambda I is called the characteristic matrix of the square matrix A of order n, where I is the unit matrix of order n. Next characteristic polynomial, the determinant A minus lambda I, which is an ordinary polynomial in lambda of degree n, is called characteristic polynomial A minus lambda I. Then when we make it equal to 0, that is called characteristic equation. The characteristic equation A minus lambda is 0 is called characteristic equation of A. The roots are called characteristic roots of the matrix A. Let us proceed to solve a problem. Now the question is find the eigenvalues of the matrix A is equal to 3, 1, 6, 2. Now solution. Here A minus lambda I is equal to 3, 1, 6, 2. This is the matrix given. Lambda I is the corresponding unit matrix. This much, which is equals to 3, 1, 6, 2 minus lambda 0, 0, lambda, which is equals to 3 minus lambda, 1 minus 0, 6 minus 0, 2 minus lambda. So this is the matrix, which is equals to 3 minus lambda, 1, 6, 2 minus lambda. This is called a characteristic matrix of A, which is the characteristic matrix of A. Now A minus lambda I determinant. This is equals to 3 minus lambda 1, 6, 2 minus lambda. This will be then determinant. So this is equal to 3 minus lambda into 2 minus lambda minus 6. This equals to 6 minus 3 lambda minus 2 lambda plus lambda square. 3 into 2, 6. 3 into minus lambda minus 3 lambda minus 2 lambda plus lambda square minus 6. So this is equals to lambda square minus 5 lambda. So we get lambda square minus 5 lambda, which is is the characteristic polynomial of matrix A. Then the eigenvalues of matrix A are given by lambda A minus lambda I determinant is equal to 0. Means lambda square minus 5 lambda is equal to 0. This gives us lambda into lambda minus 5 is equal to 0. So this gives us lambda is equal to 0, lambda is equal to 5. So lambda 1 is equal to 0, lambda 2 is equal to 5 are the required eigenvalues of the matrix A. Required eigenvalues of the matrix A. So the given matrix has eigenvalues, that is 0 and a 5. So with this, our first problem is now solved. Our second question is, find the eigenvalues of the matrix A is equal to 2, 1, 0, 0, 2, 1, 0, 0, 2. Solution. We have A minus lambda I is equal to 2, 1, 0, 0, 2, 1, 0, 0, 2 minus lambda I means 1, 0, 0, 0, 1, 0, 0, 0, 1. The corresponding unit matrix is equal to 0. So this gives us 2, 1, 0, 0, 2, 1, 0, 0, 2 minus lambda 0, 0, 0 lambda 0, 0, 0 lambda. This is equals to 0. So this implies 2 minus lambda 1, 0, 0, 2 minus lambda 0, 0, 0, 2 minus lambda is equal to 0. So this implies so 2 minus, taking the first column, we will get 2 minus lambda 2 minus lambda 0, 0, 2 minus lambda. Then minus 0 plus 0 is equal to 0. So we are expanding this determinant, taking the first column only. So this equals to 2 minus lambda, 2 minus lambda square minus 0 is equal to 0. Which is equals to 2 minus lambda cube is equal to 0. So lambda is equal to 2, 2. Hence, the required eigenvalues are lambda 1 is equal to 2, lambda 2 is equal to 2, and lambda 3 is equal to 2. So these are the eigenvalues of the given matrix A. Now let us proceed for the next problem. So our next question is, find the eigenvalues and eigenvectors of the matrix A is equal to 1, 1, 4, 1. Solution. Here A minus lambda I 1, 1, 4, 1 minus lambda 1, 0, 0, 1. This is equals to 1, 1, 4, 1 lambda 0, 0, lambda. So this is equals to 1 minus lambda 1, 4, 1 minus lambda. Now A minus lambda I determinant equal to 0. This implies 1 minus lambda 1, 4, 1 minus lambda determinant is equal to 0. So this implies So this implies 1 minus lambda square minus 4 is equal to 0. So this is 1 plus lambda square minus 2 lambda minus 4 is equal to 0. So this gives us lambda square minus 2 lambda minus 3 is equal to 0. So this is equal to lambda square minus 3 lambda plus lambda minus 3 is equal to 0. So this is lambda common, lambda minus 3 plus 1 common, lambda minus 3 is equal to 0. This gives us lambda plus 1, lambda minus 3 is equal to 0. So this gives us lambda is equal to minus 1, 3. Hence, lambda 1 is equal to minus 1, lambda 2 is equal to 3 are the required eigen. So we are getting the eigenvalues for the matrix A. The eigenvalues are minus 1 and 3. Now let us proceed to find the eigenvectors. Let x1, x2 be the eigenvector corresponding to lambda 1 is equal to minus 1. Then 1 plus 1, 1, 4, 1 plus 1, x1, x2 is equal to 0, 0. So what actually we have done? We are putting in place of lambda minus 1. So the Eigen matrix of A multiplied with x1 x2 is equal to 0. So here the Eigen matrix 1 minus lambda 1, 4, 1 minus lambda. This implies 2, 1, 4, 2, x1, x2 is equal to 0, 0. This is 2x1, x2 is equal to 0, 2x1, x2 is equal to 0, 4x1 plus 2x2 is equal to 0. So one step is here. This is 2x1, x2 after multiplication, 4x1, 2x2. So this is equal to 0, 0. So now we are getting these two equations. These two equations are identical, which is 2x1 plus x2 is equal to 0. From which we are getting x2 is equal to minus 2x1. Taking x1 is equal to 1, we get x2 is equal to minus 2. So x1, x2 is equal to 1 minus 2 is the Eigen vector corresponding to Eigen value lambda 1 is equal to minus 1. So we are getting one Eigen vector corresponding to the Eigen value lambda 1 is equal to minus 1. Let us proceed to find the second Eigen vector. Let x1, x2 be the Eigen vector corresponding to lambda is equal to 3. So then we have one minus 3, 1, 4, 1 minus 3, x1, x2 is equal to 0, 0. This implies minus 2, 1, 4 minus 2, x1, x2 multiplied with the matrix is equal to 0, 0. So this implies minus 2x1 plus x2, 4x1 minus 2x2 is equal to 0, 0. So this implies minus 2x1 plus x2 is equal to 0. 4x1 minus 2x2 is equal to 0. So this implies 2x1 minus x2 is equal to 0. Both represent same equation. So if you multiply minus 1, we will get this. And if you divide throughout by 2, we will get this equation. Now, this implies x2 is equal to 2x1. Taking x1 is equal to 1, we get x2 is equal to 2. So, the required Eigen vector x1, x2 is equal to 1, 2. So required eigenvector this, which is the vector corresponding to lambda is equal to 3. So hence the required eigenvectors are 1 minus 2 and a 1, 2. So we get the eigenvectors corresponding to lambda is equal to minus 1, corresponding to lambda is equal to 3. So with this our third problem is solved. I have completed the topic for my today class. I shall meet you with a new topic in my next class. Till then, goodbye.